All right. Hi, everyone. This is Apurva, and I am an AI focused developer advocate here at MongoDB. Thank you so much for tuning into today's live stream. I'm tuning in from sunny, well, currently incredibly rainy California. Tell us where you're tuning in from. Drop that in the chat. Would love to see where everyone's joining us from. So today we are going to talk about building multimodal AI applications with Voyage AI and Pixeltable. So super excited to have Alison Hill, VP of Product at Pixeltable, and Marcel Kornacker, founder and CTO at Pixeltable, here with me today. Welcome, Alison and Marcel.
Thank you, Parva.
Thank you
All
for
right.
having us.
Thank you for being here. All right, some quick housekeeping before we begin. This live stream will be available on YouTube after the fact. So if you miss something that we say live today, you can always go back and replay that on YouTube. All participants will be muted. So if you have any questions or something to share with others on the live stream, please drop that in the chat. And finally, there will be moderated Q&A towards the end where we'll cover all your questions. So don't worry if we don't get to your question immediately during the live stream. All right. Are we sharing my screen? Just want to make sure. Perfect. All right. With that, let's get right into it. I'll first talk a little bit about Voyage AI, and then I'm going to hand it off to Alison and Marcel to talk about Pixeltable and show you a live code walkthrough of how to build multimodal applications with Voyage AI and Pixeltable. So, for those of you who aren't familiar with Voyage AI, it's a company that makes embedding and re-ranking models that MongoDB acquired almost a year ago now. So, at Voyage, MongoDB's goal is to redefine our already battle-tested platform for the AI era by bringing the power of advanced retrieval and world-class embedding models from Voyage AI to Atlas. And as of last month, you can obtain, say, the Voyage AI API keys from within Atlas. And we've also opened up an auto embedding feature using Voyage AI's embedding models for public preview for all of you as well. Now, Voyage AI's main business is to build cutting edge embedding and re ranking models. And they have a few different classes of embedding models. There's text, contextualized, and multimodal embedding models, and also domain specific embedding models for certain niche domains like legal, finance, and code, which have their unique vocabulary, if you will. They also have re-rankers, text-based for now, but I'm sure we'll start seeing other modalities there as well. Now, I understand that these might be new topics for some of you. So we have a lot of blogs and materials that I can share with you after I'm done here for you to get familiar with these concepts and models after today's live stream. But for today, we are going to focus on Voyage's multimodal embedding model, specifically the latest one in the series called Voyage Multimodal 3.5 that we released just last month. Now, this model is the first of its kind embedding model that natively supports videos. So you'll find a lot of multimodal embedding models on the market that support text and images, but the unique thing about this one is video support. So you can basically embed videos, images, or interleave combinations of text, images, and videos just as easily as you would embed just text. The architecture of this model is inspired by vision language models. So it passes all of these different modalities through a single transformer encoder, while clip-based multimodal embedding models have different encoders for visual and text components. And we've done extensive benchmarking on this model, just like we do with any model that we release. And we found that our latest multimodal model outperforms its own previous gen counterparts, as well as other multimodal models from Cohere, Google, and Amazon, a lot of which are clip-based on documents containing visual elements. And finally, because of that unified encoding architecture, you can use the same model for text only, as well as multimodal use cases without sacrificing accuracy. And this is not typical with multimodal embedding models. Typically, you'll find that text-only embedding models are better than multimodal embedding models for purely text data. But that's not the case with this model because we have that unified architecture. But yeah, that was my quick, speedy run through of our latest multimodal model. And with that, I'm going to hand it off to Alison and Marcel. So over to y'all.
Thank you, Parva. You can keep sharing your screen and maybe we could advance to the next slide.
Sure.
Thank you. So hi, we're here from the Pixeltable team. We're here to introduce Pixeltable to the Voyage AI users. So Pixeltable is an operational data platform for multimodal AI. So what does that mean? You can go to the next slide. So if you've been working with any kind of media data, which includes images, video, audio files, PDF files, you know the pain of if you want to make a searchable collection of videos, how many steps you have to follow just to get to the point where you can see the system actually working. But maybe it's not really a system that you'd like to maintain, and it's not really a system that you can introspect and have observability into. So a lot of times when we talk to our customers, we hear about people's examples of uploading videos to S3, having to extract frames, sending frames to OpenAI Vision API, handling retries, parsing responses, validating JSON. It goes on and on and on. And then you've got about 1,000+ lines of glue code, and you're still trying to figure out how to get versioning, observability, lineage, scalability, and parallelization. So this stack might look familiar to you, and this is exactly the kind of problem that Pixeltable is solving. Go to the next slide. So what is Pixeltable? It's an open source Python software development kit. You can pip install Pixeltable and use it just the way I'm going to show you in this notebook today. You can find us on GitHub. Pixeltable is designed to enable you to store, transform, index, and iterate with different types of data. So it's a unified API that works for text, images, video, and audio. So it's a perfect match for Voyage AI's embeddings because you can use them with text data, you can use them on video, images, all of the different media types that you'd like to work with. You could have a single API for being able to work with that data in Python. Pixeltable also, it allows you to track changes and maintain data lineage as you're working. So any changes that you make to your data, any processing steps, any embeddings that you add, any models that you use, you can see all of those in what's called the table schema. And I'll show you some examples in the notebook. Okay, you can go on to the next slide, Apoorva. Thank you. So one key concept that we'll be talking through as I walk through the notebook today is that Pixeltable is both storage and orchestration within a deceptively simple table API. So if you're familiar working with data frames in memory in Python, the API should look pretty familiar to you. But what's really under the hood is that Pixeltable is organizing a lot for you. And it's organizing both the storage of your media data, including anything that you output from generative AI models, any embeddings that you have. It's also orchestrating pipelines. So what we're going to do is walk through some examples where anytime you add new data, the table itself is the orchestration piece. So this example that I'm showing here shows you how, in a fictitious pipeline, you might have files that are referenced in S3. When you put them into a Pixeltable, you can create video clips, you can extract audio, you can transcribe the audio to get text, you can summarize the text, you can get embeddings, build an index. All of this is possible within a deceptively simple table API in Python. So next slide. So we'll start with the code walkthrough. Let me switch. Hold on a second, Pedro. Okay, I think we can bring up mine. Perfect, thank you. So in this walkthrough, we're gonna go from 0 to 30, basically building a multimodal shopping agent with Voyage AI and Pixeltable. So what we're gonna walk through is this pipeline. So we're gonna start with data. We're gonna start with some Amazon products data in a Parquet file. We're going to generate some Voyage AI embeddings using both a text column as well as an image column of product images. And then we're going to use Pixeltable's built-in similarity functions to be able to query by text so that we can search both the text embeddings and the image ones as well using the same API in Pixeltable. And then we're going to build a simple agent that can choose which search it wants to do. So we're going to let the agent be able to decide if it wants to use text or image search to be able to find the right product to meet a user's need. And then I'm going to leave it at the end, but exercise for the users, you can use the Voyage AI re-rankings models, which gives you a little bit better tuned in, outputs. So in this notebook, we're going to walk through importing some Amazon listings into a Pixeltable table. We're going to add embedding indices, search for similar items, build a reusable query function, and get to building a multimodal agent. And we're going to be using these models today from Voyage AI. So Voyage 3.5, the re-ranker is 2.5, and then the multimodal search that Porva just mentioned, multimodal 3.5 that was just released last month. And then the component of Pixeltable will be providing all the AI data infrastructure. So it'll be storing the data, managing the indexes, and orchestrating the pipelines. And a few things to highlight about Pixeltable before I jump right in and start throwing code at you is that Pixeltable is AI data infrastructure. So it's incremental by default. Anytime we add new data to our table, only new rows get processed. So this includes embeddings, transformations, and model calls. Embedding indexes and similarity search are first-class table operations. So they're not separate vector databases. Retrieval lives alongside your data. Images, video, audio, and documents live in table columns. So Pixeltable actually has a multimodal type system. And if you go to docs.pixeltable.com, you'll see this detailed on our docs site. And also inputs, intermediates, and outputs all stay queryable. So nothing disappears. Everything is inspectable and versionable in Pixeltable. So to get started in our notebook, you would install Pixeltable, Voyage AI. We're going to use OpenAI for our agent as well. So if you want to get that far in the notebook and follow along, you would also need an OpenAI key. Here we have Voyage AI API keys already set up, but you would need to set those up as well. And then I'm importing Pixeltable and then also all the Pixeltable functions as PXTF. So anytime you see me using a Pixeltable function that starts with PXTF, this is one of the built-in UDFs that Pixeltable provides. Pixeltable provides a number of UDFs that enable you to work with all the different kinds of data, the multimodal data types. So there's video functions, audio functions, image functions, and there's a number of other functions as well. If you look on our website, on our docs.pixeltable.com, you can see all of the built-in functions and integrations that we have. So with the Pixeltable project, I'm going to use a directory to organize my tables because I'm going to create a few tables in this notebook. So I'm going to start with a fresh directory. I dropped the current directory because I've been working with it a lot. But if you're following along, all you need to do is create a new directory. This is basically just creating a namespace for me to be able to organize my tables. You can view all the directories in your workspace by doing pxt listders. I'm not going to show you mine because mine's a mess. I've got a ton. So the way to get started is we're going to load some Amazon product data. So this is some product data that is available via Hugging Face and a Parquet file. It includes product names and descriptions for about 1,800 Amazon items, about 500 products total. So there's a lot of duplicates there because it's a marketplace and there's a number of different vendors that offer the same item. And each product has about 1 to 7 images. So the dataset URL is actually hosted on the Pixeltable docs website. I'm reading in the dataset URL here, and then I'm quickly importing it into as a data frame in pandas using read parquet. And then this is my first Pixeltable code. I use create_table to create my first Pixeltable. Here I'm creating it in the directory e-commerce search that I just made, and I'm calling it products. I'm also giving it a handle products that I use in the session. And you can see the source is that data frame that I just imported from the Parquet file. And then you can see here that I'm specifying schema overrides. So we have some string columns, we have an image column. I'm also using on error ignore. So that basically means that Pixeltable will skip those rows where Amazon image URLs have expired. So that means that we won't get slowed down by bringing in some expired listings here. So scrolling down, Pixeltable can work with files from anywhere. So you're seeing me here load a Parquet file from a URL and then loading that in. But Pixeltable can also work with files from local paths, URLs, as well as cloud storage. So if you look on our website on docs.pixeltable.com, you'll see some tutorials, especially for working with remote files like video files and image files located in S3, for example. So once I've imported that, you can do pxt.list_tables. And this is just listing all the tables in that directory. And so what you would see is that I now have my table that I just created called products. And the cool thing about Pixeltable is that I can also filter and clean up the data in my table before applying models like embeddings. So the embeddings are going to be most useful if I have no blank rows. So I need to remove some rows where the about_product field is none or empty, because those won't produce useful embeddings. So you can see here that I'm deleting those rows, and 37 rows were deleted. And then if I count the rows that are remaining here for us to work with, we've got about 1740 rows to be able to work with of items. And then Pixeltable queries work like you'd expect. So we can select to pick columns, we can refine with order, by, and where, we can collect to execute a query and return results. And we can also control how many rows come back through a few different commands there, limit, head, and tail. So here, I'm just going to show you a peek of the kinds of products that we're working with once we've imported them. So I'm selecting 4 columns here in my table, and I'm showing you just the last 3 rows that were inserted. So you can see I have a tank plastic model kit, and the images are visible right away because I loaded them in as PXT image. So those are the first 3 rows. You can see that sometimes there's more useful about_product information than in others. Some it's long, some it's short. We also have price. And you can just filter rows with simple keyword matches. For example, we're obviously going to improve upon this with embeddings, but here I'm showing you that there are in fact products in this database that include the word dino in them. So here I'm searching the about product column for the word dino, and I'm just selecting 3 and collecting that. So you can see that we do in fact have some dinosaur toys in here. And then here we do have some that are a little bit different. The image might be different. The description is pretty similar. So there's definitely some dinosaurs in this product catalog, and there are also duplicate items, which is par for the course when working with Amazon Marketplace data. So that's the data in a Pixeltable. We've created it. We can now work with it. And in Pixeltable, we can add an embedding index. We can attach an embedding index to any column. So I'm going to actually add 2 right away to the same table using separate Voyage AI models. This allows us to capture different signals for the text embeddings versus the image embeddings. You can also query each one independently, and you can also add more indexes later without touching the existing ones. So you can compare models, methods, side by side in the same table. So first, I'm going to add text embeddings on the about product column. So here you can see that the function is add_embedding_index. I'm giving that index a name. I'm calling it text index, IDX. I'm applying it to the column about_product. So these are the product descriptions. And then I'm giving it the Voyage AI embeddings model to use. I'm also going to add an image embeddings index in the exact same way. So this is all the exact same code. I'm just changing the index name and I'm giving it a different model, but it's all the same. And now if you look at the table, if you print it, so just products is the name of the table. This is the table schema that we're looking at. So you can see that these were all the columns that I inserted at the start. I inserted a unique ID from the Amazon products parquet file, a product name, a category, selling price, about_product image. And then now I have this text_index and this image_index. And you can see that in the schema, you can also see the embeddings models that were used. So this is our way of being able to track the lineage of the table. And as you work, you can always check in, see the schema of the table again. As you add columns, as you change things, you can see your schema evolving as you work. So what just happened, Pixeltable sent each product description and image to the Voyage AI embeddings. They stored the resulting vectors, and Pixeltable built 2 searchable indexes for us. So just in those few steps we've already done, you didn't see me set up a separate vector database, an ETL pipeline, a cron job. The indexes all live in the same table as the data. And whenever I insert new products into this product table, everything would update incrementally. So the Voyage AI APIs would compute embeddings for only the new products. The index would add the new vectors, and we can search right away without reindexing or reprocessing any existing rows in our table. So now that we have indexes, we can do search right away in Pixeltable. So Pixeltable provides a similarity method on any column that has an index attached to it. So you can pass it a query, and it works like any other expression, where you can use the order by, select, where, all of those functions that you're familiar with for being able to refine the output and inspect it. So we now have 2 indexes that I created, and I have 2 ways to search. So we have text search, pass a text query, and find products whose about_product descriptions are semantically similar. And then also image search. So I can pass a text query and find products where the image embedding actually indicates that they were, matched visually or close in the embedding space. So I'm going to show you how to search for both. So we're going to start with a text query on just the product descriptions. So for text query here, my text query is I want to look for realistic, scientifically accurate dinosaur figurines. I do this a lot when I'm preparing for birthday parties for children. So the way we would do this in Pixeltable is the about product column is the one that has the text index attached to it. We can use the similarity function. The string argument here is used because I'm passing it a text query. And then here I'm naming the index because there's multiple indexes in this table. So you have to tell it which index. And this is optional, but I'm setting a similarity threshold because I found that it's easier to set it once and then be able to use the variable later on. You can use just a constant as you're working and as you're exploring and change it, see what else, see how the results differ based on different thresholds. So I have that query. I've given it to the similarity function. I've saved the output as text similarity, text_sim. And here I'm going to just compose a query from the similarity expression. These results aren't stored. They're not persistent like a Pixeltable database, but they are here for exploration and they're very useful to be able to create just an in-memory object, text results. And then here I can search for it. You can see that these are my scientifically accurate, realistic dinosaur figurines. So these were the most similar to that query that I just entered. You can see that the scores are, I think, all 0.864. So that's the similarity score that it's returning. And you can see that these are actually pretty similar. Now, this embedding index didn't have access to the images. It was just based on the about product. But you can see that there's, words in there that would definitely get you to think that these are, scientifically accurate figurines here. Movable lower jaw. I think these are actually pretty cool little T-Rexes. So for the cross-modal search, that's where I used that different model. So I used the Voyage AI Multimodal 3.5 model. So for this model, we pass a text query and we search across images. So the model maps both modalities into the same embedding space. So I can search for plush, cuddly, stuffed dinosaur, and it might find products that look softer than, scientifically accurate dinosaur figurine. So here I'm doing the exact same workflow that I used before. So I'm using the similarity method. My string is plush, cuddly, stuffed dinosaur. I'm telling it the index is image index, and it's on my image column. And here I'm just showing you the top 3 results. So now these scores are a little bit lower. They're 0.59 and below, but you can see that these are all stuffed dinosaurs. The last 2 ones are a little rattle set, so they're definitely cuddly and soft, plush dinosaurs. So that shows you that we've already been able to generate embeddings. We've already been able to do similarity search. And now we want to build reusable retrieval queries. So what I just showed you is really useful for exploration and being able to kind of do some sanity checks on your embeddings, make sure that they're working as expected. But you also might want to make those searches reusable and persistent. So in this section, I'm going to define a PXT query function for text and for image search, and then wire them into a table so that the results are computed automatically upon every insert. So every time I insert a new query, it'll give me the results back in a table that's persistent. So this gives me 2 things. It gives me a way to test and inspect search results, but it also gives me reusable query functions that I'm going to later hand on to an agent as tools. So there's 3 steps here. I use a query function in Pixeltable, pxt.query. And I'm going to create one for text search and another for image search. And then I'm going to create a dedicated table with a column for those query strings. And that'll store my queries as a row. And then finally, we're going to add a computed column that calls these query functions that I just wrote. So this is really the orchestration layer in Pixeltable. It runs the search functions automatically whenever a new row is inserted into this table. So here I'm essentially just saying the same thing that I created before with my similarity searches, but I'm putting it into a PXT query. So I'm saying that my text search is searching with a certain query text, and it's searching this index, and it's returning the same fields that we looked at before. And then same with image search. So I'm just defining both of those 2 PXT queries, and then I'm going to use those in this new table. So in this table, I create a new table. It's in the e-commerce_search directory. It's called Searches Live. And this is the one that I'm going to use to hold my user queries and be able to store the results. So you can see it's just a table with one column. It's a type string. So this is just a query that I insert into the table. And this is the schema. We don't have anything computed with right now, but we're going to add that. So we can add 2 computed columns that each call our query function. So this is that orchestration layer again. Pixeltable will run them automatically on every insert. There's no rows currently in this table, but I can go ahead and set up the workflow by adding these computed columns to the table now. So you can see I'm adding a computed column that's going to be called text results, and that uses my, my text search query. And I'm going to add a column called image_results. So I've added those to my table, but they're still just in the schema. You can see that if I do searches, which is this table name .count, you can see there's 0 rows there. So there's no data there now, no queries. But now I can insert queries, and what's going to happen is that table is going to act as a workflow. So I can insert 3 queries: realistic, scientifically accurate dinosaur figurines, colorful, cuddly plush dinosaurs, and then teach math skills with dinosaurs. Those would be my 3 queries. All totally accurate queries that I have entered into Amazon. So here's the example of what actually happened when I inserted those. So Pixeltable went ahead and computed the text results and the image results. It used those PXT query functions that I designed. Now this output is pretty ugly. This is the actual JSON output that's provided by the by those functions that I wrote earlier. So it looks different from the similarity results. It's really because before I had 1 row per product in the original table. And so it was a kind of nice clean table rendering, and you could see images. Now I have 1 row per query with the search results stored as a JSON list inside a single column. Pixeltable gives you some functions to be able to work with JSON lists like this. So here I'm showing you how I can pull out the first, I believe, 3 to 4 of those text results. So these are looking at the text search output in that searches table. So here you can see the queries. So I have 1 row per query that I inserted, and then I have the text matches here. So you can see that, like, for math skills for dinosaurs, you get learning resources, Dino Math Tracks game. Now, obviously, there's some duplicate items here, but sometimes there's different ones, and sometimes there's ones that are a little questionable, like the one for colorful, cuddly plush dinosaurs gives me some like animal figurine set with a wild zoo. And then we can do the same thing for the image search output. So here, this is really just kind of a smell test to show you that the searches table is actually working. It's providing these searches, and you can see the output right away in the table, and these are stored persistently for me. So if I leave this session, if I leave this notebook and I come back to it, I've still got this table stored in my Pixeltable database. So at this point, we have the building blocks. We have a product table with 2 embedding indices that we can search. We have similarity search that works across text and images. And we have reusable query functions that are wired into an orchestrated workflow. So in this last section, I'm going to show you how we can hand those query functions to an LLM as tools and let it decide how to search, because you've still got these 2 different indexes that you would need to be able to search on. And you'd like to be able to have some kind of like unified view of, as a user, what you want to search for, and just tell me what's useful and relevant to me based on my search. So in Pixeltable, you can build a multimodal agent. So this is really infusing an agent with the ability to be able to know more about the data that's in this catalog. So some searches could be solved by reading the product text description. Others might be about what the product looks like, not necessarily what's in the listing. And so we're going to give this agent 2 tools that are each powered by the Voyage AI embeddings, and it can choose the right retrieval path based on the question. So the flow here is that the LLM receives a question and decides to call a search tool, either text or image. Pixeltable will execute the search and store the results. And then a second LLM call will assemble a final answer from what the tool found. So this is a pretty complex workflow, but it's one that I think showcases a lot of the really neat tools in Pixeltable that allow you to go from asking a question to being able to provide a scalable, persistent answer that's reliable. So as we go, every step is a computed column. So the whole chain runs automatically when you insert a new question. So the agent is going to use OpenAI for the LLM calls. So you would need to set up an OpenAI key here. And then we're going to use this function pxt.tools. So this takes our query functions that we already defined, text search and image search, and it generates the tool schema that OpenAI's API expects. And we're going to pass this to a few other steps as we go. So we're setting us up with these agent tools, text search and image search. And the agent table is going to have one input column, and that's just the question. So everything else will be computed. So we're going to create this table. I'm calling it mm_agent. And it just has a question, a single column that's a string. And then here I'm going to set up a system prompt that tells the agent what tools it has. So you can see I say you have two tools, text search and image search, and when to use each one. And then there's also some boilerplate words here that tell it how to be a helpful personal shopping assistant. So to that table that I had a question column in, I'm just going to add a single computed column here at the top called LLM response. So this is using our OpenAI integration to generate chat completions, where the messages are given to it with a system prompt and then the question that's entered into the table. And then it's using these two agent tools as the tools. So text search and image search. And then the second computed column I'm adding is a place to store the tool results. OpenAI invoke tools is the function that we're using, and we're giving it the agent tools and the LLM response from this previous column that we just generated. So this is how we kind of chain things together. This column will only compute once this column is done computing, and this is how Pixeltable can orchestrate this workflow for us. So I still don't have any questions in this table. This is, again, just building up the workflow as an orchestrated pipeline that is ready for us to be able to insert a question into. So I've hidden this cell. You can look at it. It's a pretty complicated UDF, but it's really just to get back some better structured and formatted data, because many of these calls are producing a lot of noisier output that's a little bit more difficult to showcase in a notebook setting, but they're probably ones that you're used to if you've been building apps and working with LLM responses as JSON formats. So there's two more computed columns that we need, and these are using these UDFs that I defined in here. And these are all in the notebook that's available on the GenAI showcase for MongoDB. So we assemble an answer prompt, and then also we assemble an actual user-facing answer. So these are all just little stepwise things that we're doing to be able to format the output in a way that's more consumable for a human user. So you can see that after those steps, I have this new table called mm_agent. This is my multimodal agent table. I am inserting only a question here. You can see that that's the only column that is blank for computed with. And then I have all of these columns that I just built up as computed columns. So this is the orchestration piece. So we have an LLM response, and you can see that the actual functions that I'm using for each one of these are saved as computed with. And I'm building up my tool results, an answer prompt, and then finally the answer that I'll be showing people. So if you look at that computed with column above, that's really like the table is the workflow documentation. So you can see the entire agent pipeline, what depends on what, and Pixeltable orchestrates the execution of these different columns as it goes. Every time I insert a new row, it'll incrementally compute the new columns. So if the pipeline is ready, that means we can give it some questions. Here I'm inserting 3 questions here. So find me realistic, scientifically accurate dinosaur figurines. Show me some colorful, cuddly plush dinosaurs. And what's a good toy to teach math skills with dinosaurs? So with that insert, Pixeltable runs the full chain of all of those computed columns. And here's an example of what we can inspect. So here I'm just doing a simple select on this table. You can see the question and the answer. So for realistic, scientifically accurate dinosaur figurines, it recommends the Schleich North America Tyrannosaurus Rex toy figure. For math and math skills for dinosaurs, we've got the Dino Math Tracks game. And then for colorful, cuddly plush dinosaurs, we have the T-Rex plush, as well as some little rattle sets. So you can see that this is pretty much mimicking exactly what we showed in the similarity search, but it's able to go across the different text and image descriptions, make those decisions for us, and then format the results in a helpful shopping assistant kind of way. So you can check the tool's answers against our text similarity search. So here I'm just showing you one row back from that again. This is what we showed earlier. And then checking the tool's answer against the image similarity search as well. So you can kind of spot check, you can tell and check your agent's work and be able to really quickly kind of see the process by which it arrived at the different answers and outputs. So I'm going to stop there with the notebook. We have an additional section on improving results with re-ranking models that'll be in the notebook for you. That shows you just a way to be able to use the Voyage AI's re-rank 2.5 to be able to refine the top answers and the results. And you can see the differences between the different kinds of outputs, and they are a little bit more nuanced based on the question that the user enters. So I'll leave that for later, and we can take any questions that came up, Apoorva.
Awesome. Thank you so much. I really enjoyed seeing that end-to-end walkthrough. It really seems like a lot of powerful capabilities in one place with Pixeltable. I'm gonna give folks just a second to see if there's any live questions they have, but otherwise I did record some
Awesome.
questions that were coming through. Okay, while folks are thinking, let's take a few questions, shall we? So one question was, what are some of the most common ways that you're seeing customers using Pixeltable right now?
Yeah, I can jump in there.
Yeah.
So it's definitely the orchestration piece. So what we just saw, basically stringing together operational pipelines that include generative AI models, but also indexing and so forth, is doing it with Pixeltable. It's just keeps it really simple. You can focus on your application logic. And so we have some users that are also using it for data set curation. When you do model training, Pixeltable comes with versioning, lineage, and you have observability via the version history and also the schema. But what's common to all of them is everybody does some form of orchestration and kind of, basically running these things. So yeah, so that's kind of the core use case.
Awesome.
I'll add to that too. I think the one thing that we hear a number of people say around that use case that Marcel just outlined was the fact that Pixeltable allows you to handle API errors really easily. So when you're doing these LLM calls, Pixeltable does have like the ability to be able to do retries, to be able to see errors. So when you're doing these batch, submissions to LLMs, it's really nice to be able to see that. And then that kind of keeps that operational layer intact for many people who are doing this at scale with large data sets.
Awesome. On that note, there was another question on what are some best practices for using Pixeltable with data at scale?
So today Pixeltable is only available through a local SDK. So that limits your resources to a single machine, so which is typically okay for orchestration purposes. You can also, if you're using a cloud database, basically export the output of your orchestration calls pipeline into external RDBMSs. So you can use Pixeltable in conjunction with external, cloud-hosted relational database systems such as RDS or Google Cloud SQL.
Cool. Awesome. There's a question here. Is Pixeltable a replacement for vector databases?
In essence, yes, because it subsumes vector databases. So typically what you do in a vector database is you have a separate pipeline that computes embedding vectors, and then you need to stick it into the vector database. And then when you get a query, you query the vector database and then assemble your output again, right? So it's kind of part of the entire workflow. And in Pixeltable, all you need to do is add an embedding index declaratively to a column that contains the data you want to search. And then you can simply formulate queries and do everything else too. So if you're getting an image back, you can actually do something like resize or put a filter on the image. If you're getting a video back, you can do things with a video. It basically makes it part of your entire workflow. Typically, you need to do things in your application just beyond the index lookup. So Pixeltable facilitates doing all of the steps in one system and one process.
Makes sense. Alison, did you have anything to add there? Just wanted to check before.
Perfect.
Okay. I have two more questions here. So how does Pixeltable work with traditional MLOps tools like Airflow?
Pixeltable, if you're using Pixeltable, you wouldn't probably use Airflow. You could probably, that said, if you use Airflow to insert things into Pixeltable, that would work. But the other way around, like Pixeltable is its own system that does dependency tracking between these computed columns on a very fine-grained basis. So it gives you kind of a much more granular breakdown of a workflow, and is also able to do automatic parallelization based on the expressed dependencies in your computations.
Got it. There's one more that just came in. How can developers integrate MongoDB as the primary data store for product catalogs with pixel tables, multimodal tables, and Voyage's embedding models when building a shopping agent?
That's a good question. That's a work in progress, actually. We don't have a MongoDB integration yet, but we're interested in adding that. So basically having Mongo both as an input source, being able to import data from Mongo, but then also as an output source, right? When you run any kind of orchestration inside of Pixeltable, to designate it as a destination where the output lands. Those are all things that are possible, and that we'd be happy to add.
Awesome. Well, I think that's all the questions that we had. Is there anything else you all would like to share with our audience here?
Check out our docs if you want to learn more. There's a number of cookbooks and use cases that we have. So there's a use cases and deployment tab on our docs that might be useful to some of the attendees here to be able to see all the different kinds of ways that people are using Pixeltable for orchestration, for building multimodal apps, for example, and for curating data sets. So that'll give you like a good lay of the land, kind of like 10,000 foot guide of like all the different things that are possible, because Pixeltable is like a whole platform and ecosystem around in open source tools. So there's a lot that you can do, and fitting it all into a notebook is challenging, a single notebook.
Definitely. Well, awesome. Thank you so much, everyone, for tuning in. And thank you so much, Alison and Marcel, for sharing everything you did with us here today. It was really great having y'all here.
Thank you, Apoorva. And thank you for the great questions. Those were great.
Yeah, thanks for having us.
Thank you. Bye.